Alright folks, today we're going to put together the last couple times. We're going to see translations on a graph happen at the same time as scale changes. So we're going to start out with some note card information. If you have a note card with you, you can write this down. If not, you can get one when you come back. But we'll title it this, and we're putting some of this information on a note card. Some of it I'm going to tweak a little bit. Okay, so we've seen this already, but instead of having this a as divided by, we're going to write it as the reciprocal of a, like we have been talking about it. That way we don't ever have to worry about a fraction inside of another fraction. And then the only thing you need on your note card is the amplitude is the absolute value of b. The period is 2 pi times the absolute value of a, and we're going to add on this part right here just next to it, or pi times a for tangent. Okay. For tangent, another thing that's a little bit different, the amplitude isn't going to exist for tangent, and we'll talk about that when we see an equation that uses it. Okay, so if you need to, pause the video, write that down. Otherwise, we'll make sure you get it when you come back. So what we're going to do differently this time than what we have been doing the last couple lessons is we will see a, something in front of x, and an h plus or minus inside with x at the same time. And when that happens, you have to factor out whatever number is in front of the x. So go ahead and write down factor, and then we'll do it right below here. So the 4 is coming out, and we're left with x plus pi. We're going to use this pi instead of the 4 pi when answering the questions. Okay, so we're going to do C through F first and then come back to do the domain and range, because these things dealing with what we see in our equation may affect domain and range, so we'll leave those until last. Okay, just looking at your note card, the amplitude is the B value, and that's the number in front. It says absolute value because we cannot have a negative amplitude. Okay, this one we don't have to worry about, just regular 5. Period, because we're dealing with cosine. We're going to take 2 pi times the a value. Okay, remember, if you see a 4 in the equation, let's go ahead and mark this. A is 1/4, the reciprocal. That's why you see 1 over a in your formula. So we'll take it times 1/4. Multiplying straight across, we have 2 pi over 4, which reduces to pi over 2. If you want to write it as 1/2 pi, I am good with that. Phase shift, just like with purple note card way back when, if you see a plus, it means minus, it means left. So we're going to give the direction with it. We're going to the left pi here. Vertical shift, what you see is what you get, just on the end there, plus 10. So now what we're going to do is think about domain and range in terms of regular cosine graph and what would change under scale changes and under translations. So if we think about domain, that's left to right. If you shift this up or down or stretch it out left and right, it doesn't matter with the domain. You're still going to hit every number, so it's all real numbers. That's pretty constant for domain, at least for sine and cosine. The range, it was at -1 and +1 in terms of your maximum and your minimum, but 2 values affect the vertical distance on your graph, or vertical values, and that's the front and the back, or the B value from the amplitude and the K value. If you need to on here for your letters, remember this goes with B, goes with A, goes with H, goes with K. Alright, so here's what we're going to do is go ahead and find some space to write out max and min, doesn't matter where, but we're going to find those just like we did for graphing. Okay, usually it's -1 and 1, but the amplitude has changed that to -5 and +5. But then everything's going up 10, so we're going to add 10 to both of those. So our new minimum's at 5 and our new maximum's at 15. We will say our range is from 5 to 15 included. Okay, we're always going to use brackets there. All right, let's look at another one on number 2 here. Again, the first thing you're going to do when you see something in front of x is factor it out. It doesn't matter if it goes in nicely or not. This is the first case where we see that. We're factoring out the 2 even though we didn't see something with 2 in it over there. Factoring is just division, so we're just going to take whatever you see and divide it by that number out front. So that'll be pi over 2. And sometimes you'll have to reduce with that, so watch out for that. But then we're answering the same questions here that we were on the last one, A, B, H, and K. I want you to pause the video and see if you can do that. Okay, so here amplitude is the number in front, but this is the first time we've seen a negative with it. Amplitude has to be positive. We're going to use the positive 4. Okay, absolute value B. This one is 2 pi times the absolute value of A, and that for us looks like 2 pi times the reciprocal of 2 is 1/2. Gives me a period of pi. Phase shift, we just switch the sign, negative pi over 2. And vertical shift, -5, we see it on the end. Domain, again, is all real numbers, but range, we're going to do min and max again. Okay, remember, minimum and maximum are usually 1 and -1 for sign, but the amplitude changes that to -4 and 4. Okay, we're doing the amplitude first because if we think order of operations, scale change or multiplication happens before addition or subtraction. Okay, that's next though. We're going to subtract that 5, and we have a minimum of -9 and a maximum of -1. The next couple we're going to look at are tangent, and so that's going to change quite a few things. Okay, first of all, amplitude and period, based on our A, B, H, and K, are going to look different for tangent, so watch out for that. Amplitude we talked about, because there's not a maximum or minimum. If we think about sine and cosine, the amplitude is this distance to the maximum from the center or to the minimum. If you don't have a maximum or a minimum, you can't have an amplitude. So it just doesn't exist. Okay, you can draw a line through it, you can say none, you can say undefined. Okay, but also the period of regular tangent is only pi. So instead of using 2 pi a, we're taking pi times the absolute value of a. Right, so we can do that one. There isn't a number in front of x that we see, so it's just 1, and pi times 1 is just pi. It stays the same. Now, because that a wasn't there, we don't have to worry about factoring in this case, so we'll just use this pi over 6. Switching the sign goes to negative pi over 6. Vertical shift, what you see is what you get on the end there. And then when we're talking about domain and range, I'll go ahead and sketch the little graph here to remind you. Okay, we've got tangent going through 0, 0, but what's weird about tangent is all the asymptotes that show up. And there's a bunch of them, specifically infinitely many. So when we're talking about our domain, we can't say all real numbers because we have to leave out a bunch of values throughout our values on the x-axis. And then our range, though, does hit all of the numbers from negative infinity to positive infinity. So we're going to go ahead and do that one first. But we're actually going to come back to domain because something that we're doing on problems 5 and 6 on your practice are going to help us figure out where these domain values that are asymptotes have changed to. Okay, so we'll come back to hit that one. Okay, based on what we just did with the first two dealing with factoring and finding all the values and what was different with tangent, I want you to pause the video and do everything except for the domain on this one, please. Alright, range is all real numbers. Amplitude doesn't exist. The period here is pi times the reciprocal of that number. So that's 1/4 pi. Phase shift, we have to factor the 4 out for. That's 2 pi over 4, which reduces. It might be helpful to physically write this out so you know what you did to get the number. But then once you do that division, you get pi over 2. So if it's a plus pi over 2, our phase shift is going to be negative. Okay, then our vertical shift was -4. And again, we'll talk about that domain here in a second. On your homework from last time, there was a problem dealing with composition, and this is why. What I want you to do is, at the bottom of your note card that you wrote, we're going to add this as well. Okay, and this is the composition rule, or composite. Because we've seen the scale change and the translations, but again, they happen at the same time a lot. So we want a rule that puts those things together. When you see T following S, okay, the scale change goes first. Order of operations, we know we're going to multiply before we add. Okay, so if we're given an equation, if we know the A, the H, the B, and the K, we can plug that in to come up with a rule that will allow us to plug in some points. Okay, so on problems like this, let's go ahead and fill out our A, B, H, and K from kind of like what we were doing a little bit ago. So A value, this is already factored for us. The 4 changes to 1/4. B value is the number you see. Now this one you got to be careful. This is going to be positive or negative, whatever you see. It's not absolute value, because the absolute value is only used when talking about the amplitude. So if you see a negative, it's going to stay negative for a problem like this, because we're just saying what B is. We're not saying what the amplitude is. So +3 here. H value, we're switching the sign, -pi, and K is our -10. And then all you have to do is fill in all those numbers. So start with your capital T, open for following, and then S for our scale change. Okay, so A comes first, that's the number 1/4. Then X, plus H looks like plus a -pi, we'll just say -pi, comma. And then B comes next, so 3y plus a -10 is just -10. And that's our equation. Now, why this is helpful is because when we're graphing things that have both a translation and a scale change, it's not always as easy as some of the ones that we did where only one thing was happening. Okay, so I'm just going to use an example here from our parent function. Cosine starts at the point 0, 1. If you wanted to figure out where the new point would be after all of these transformations, all you have to do is plug it in. So that would look like 1/4 times 0 is 0 minus pi. So it would go to -pi. And then 3 times 1 is 3 minus 10 is -7. Okay, so it'd be at -pi, -7 instead of 0, 1. And if you do this for enough points, you would be able to see the pattern to be able to plot the rest of them very quickly. Okay. So based on what we just did, I want you to find the composition for this one. Do watch out that you have to factor on this one. We didn't have to do that on the last one. It was done for us. Okay, pause the video and take care of that for me. A value, we're going to use 1/3. Then X plus H, when you factor this out, it's pi over 3. I'll go ahead and write it here. And so we would say the H value is -pi over 3, so we're using that directly. And then on this side, the B value is 2, but there was no K, there was no plus or minus, so we just leave it 2y. Again, if you did see a negative here, like with the amplitude, you would have to keep that negative. Okay, that will affect the points, even though it doesn't change the amplitude. So how this relates to what we were talking about with domain that we skipped over is a domain is talking about the x values, which means we can use this part of our formula to go find the new values of the asymptotes. So let's go back up to our two problems dealing with tangent. We said that the first asymptote on here, okay, happened after 0 at pi over 2. So what we're going to do, and what I want you to write here, is take ax plus h to figure out where the first asymptote is under all of those things that you see. Okay, so together here, the a value we decided here was 1 since it wasn't there. And this x value comes from any x value of the asymptotes that you have. We're going to use pi over 2 every time. You could technically use any of them. This is just the smallest positive one. Okay, then we're adding the h value. H was a negative pi over 6, so we'll use that. And then all we have to do is subtract these fractions. Okay, if you're not comfortable with fractions, you can take 1/2 minus 1/6, leaving out the pi in your calculator, and write that number down. Okay, this is 3/6 minus 1/6 is 2/6. So it's at pi over 3. So here's how we're going to start. If you recall from a few lessons ago, we're using set notation, and we're going to say x such that x can't be. We're using x instead of theta just because they do. Then our first value we came up with was pi over 3. Okay, but that only gives one of the restrictions, and we have to list all of them. Because there's infinitely many, it's not possible to actually write them all out. Instead, we'll just say the pattern, and the pattern is talking about how often they happen. The next one's at 3 pi over 2 because the distance here is pi, or the period, and that's really important. It's pi in the case of the parent function, but if you have a scale change, it will change based on that number. So we're always going to add the period. So our period was pi in this case because we didn't have a scale change left and right. And then we'll say times n because we could add pi any number of times as long as n is an integer. Okay, so here's your general form. Find some room. It's going to be x such that x isn't. First one is ax plus h. And you can use any, but we're going to use pi over 2. And then plus the period times n is an integer. Okay, this is not a note card item, only the ax plus h's, so this is something you will have to know how to write. Okay. With that in mind, I want you to try to come up with the domain on this one. Okay, remember, we're starting out with x such that x can't be, and your first job is to figure out what number goes here based on ax plus h, with that x being pi over 2. Okay, so pause the video and try to go find that value. Our a was 1/4, so we're taking that times pi over 2 and then adding the h value. Okay, our h value for this one was pi over 2, but it was negative. Okay, it comes directly from our phase shift down there. You already did the work for it. And then we're simplifying. So order of operations, we have to multiply first. So that's pi over 8, and we're subtracting pi over 2. Again, if you're not good with fractions, that's fine. Type in your calculator to get it as a fraction for me. Okay, so this is 1/8 minus 4/8, or negative 3/8 pi. And then we say it happens every period after that, not every pi after that. In this case, our period is only pi over 4. So we'll say that any number of times where n is an integer. Alright, that'll get better in practice. It's new, so it's a lot to remember right now, but you've got a few tangent on your homework to get good practice with that. Okay, next thing we're going to do is a word problem. Okay, I want you to go ahead and just start reading through that. And in general, when we're talking about word problems, or any problem on this whole second half of the chapter, when you see an equation, when you see a graph, we need to know A, B, H, and K, or the amplitude and the period, so we can answer questions about them. So here we've got an equation that's giving Darlene's height off the ground along a Ferris wheel, and it tells us that the t is in seconds, and we want to know if the ride lasts for 2 minutes, find all the times from t less than or equal to 120, which is just your 2 minutes in seconds. It talked about how your time was in seconds, but where she is closest to the ground. Okay, so what we need to talk about is on a cosine graph, what that means. Okay, so here's my cosine wave, and we're going to find these A, B, H, and K letters so that we can figure out our maximum and our minimum to answer the question. So A value has pi in it. That happens a lot of times with word problems. We've got the reciprocal looking like 15 over pi. Okay, you'll notice that it started with 25 here. That's just a K value. They could have put it on the end as well. The reason it's here is just to let us type it in our calculator a little bit easier. Okay, B value then has to be in front of cosine the 20. H they already factored out for us, so that's nice. We're going to use a positive 10. And the K value we already talked about was 25. Okay, from there, again, any type of problem that you're working with, whether it's a graph, a word problem, or something like what we did a little bit ago asking about the range, we're going to need min and max. Okay, so let's think about minimum and maximum again. Okay, remember, normally it's 1 and negative 1. This time it's changed using the amplitude to negative 20 and positive 20. Okay, then we're using our vertical shift, and that was the 25, going up 25 on both of them. So the minimum is 5, and the maximum is 45. Okay, they told us the 45 feet above the ground, so that's nice, it checks out. But now we know that the lowest part of the wheel is 5 feet off the ground, so she's not scraping across the bottom. Now, we're going to do one other thing here, and in general this is helpful. We know that the amplitude is directly 20, but what we haven't talked about yet is the period. Okay, so the period, we're going to use our 2 pi times A, just like we have been doing. And our A is that weird 15 over pi. Okay, you're going to see this a lot for word problems, I said, because those pi's cancel out. And now we have a nice 30, specifically seconds, for our lap around the circle. Okay, it takes 30 seconds to get around the circle, basically. That checks out with this information we were given. It's 2 revolutions per minute. Okay, 2 laps in 1 minute means 30 seconds for 1 lap. So we're all good there. Now we want to check out 120 seconds or 2 minutes, so it should complete 4 laps. It says at what times will she be closest to the ground. That's at what times is she at that minimum. So we should have 4 different answers here if there's 4 different laps around the circle. In general, problems like this you could do by hand. If you don't have a translation happening, it's not so bad. But because of this translation, it makes it a little bit harder to think about. For that reason, we're going to use our calculator to help us with this one. So you still have to lay out all this groundwork, because if you don't, we'll have no idea what to set our window to make sure this equation even shows up. Okay, so we can start out by just typing in our equation. They set it up exactly how you want to type it in. So make sure you have parentheses in the same place they do. Don't add in extra, don't take any away. You can use x instead of t, just like we have been doing. And then I'll just show you, if we hit graph right now, I'm at a 10 by 10 window, and we see some of it are curved, but we don't really see the right stuff to be able to answer the question. Okay, so our question wanted to look at the minimum. We have to make sure we see that. But in general, looks like a good window maybe is 0 to 50 in terms of our y values. But it also specifically told us, let's check out 1/22. So go to your window for me. And we're going to check out 0 to 120. And I'm just going to change my scale to count by 30 so we can see those periods nicely. You wouldn't necessarily have to adjust that scale to the period to answer the question. Then our minimum, we said 0 and 50 for our max. And then you can count by ones. I'm going to change it to 10 so there's not as many tick marks. Now we can see our graph pretty well. And I want to point out what I meant by being able to see the period. Okay, so I've got 30 along the bottom, but you'll notice it's the same distance because our period is max to max. And we're actually going to use that to help us with our answers here. They asked us to find all the places where Darling is closest to the ground or at the minimum height. So we'll do either second trace the minimum, or if you want, and I prefer this a lot of times, just putting the minimum value there of 5 and trace the intersection. You can see all 4 of those places that we're going to go find. Once you hit that, enter, 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 or left bound, right bound, and it's going to give you one of them. So the first one my cursor was closest to was 55, but now that we know that, we don't have to actually work hard for the other ones. Because we know the period is 30 seconds on all of these, we can just add and subtract until we get all of our numbers. So first one's 55. If I go 30 to the left, I'll be at 25. If I go 30 to the right, I'll be at 85. And then 30 more, 115. Okay, so I'm going to write them, but make sure that I put a label on at the very end. Okay, you want to use set brackets when you're writing this. Otherwise, you have to label all of them, and we don't want to do that. All right, last thing I'm going to show you is just to help you on your homework, because there's a few problems that ask you to go the other direction, and I just want to make sure that I'm clear on the directions. So they give you a parent function and some information, and they want you to just write an equation. Okay, there's not going to be any complex fractions if you use 1 over a instead of what was given divided by a. However, we do want to simplify, so that's something that's important here. So we'll do this just to show you here, and they will go pretty quick after that. I'm going to remind you what the formula is. You have it on your note card in front of you, hopefully. And all we have to do is plug in our stuff and then simplify. So starting out, we're going to use cosine. So I'm going to change this to cosine. And the phase shift is the first thing they give me. That goes in for the h value. So I'm just going to start with, if I see a positive, I have to subtract that. Okay, then they give me the period of 4 pi. Now that is not any of these letters directly, but we solve for the period by saying 2 pi times a for cosine and sine. So I'm just going to set 2 pi a equal to that 4 pi. And then solve. So dividing by 2 pi on both sides, a is 2. So 1 over a, or the reciprocal, would be 1/2. Then it says the amplitude is 2. So I'm going to start with that in the front. And vertical shift, that's our k value, just goes on the end. Before you throw it on the line, simplifying means just distribute that thing through so you don't have a bunch of parentheses here. So y equals 2 cosine. Inside we're going to have 1/2 x. But then here, if you multiply straight across, you've got 3 pi over 4. So minus 3 pi over 4. Put a minus 5 on the edge, and that's it. Okay, so this one's tangent. We got to think about what's different for tangent. You'll notice they didn't give us an amplitude because that's not a thing. Okay. They did give us phase shift, so we have an h value. They gave us the period, which we'll use to find a, and vertical shift. Okay, so here, we don't have to worry about an amplitude, so I'm starting with tangent. This tells us there has to be an a value. But what's different is for the period of tangent, we're not setting 2 pi a, we're just setting pi a. So that means a is 3, and we're going to put a 1/3 inside here. Again, we're writing it with extra parentheses to start out with. Using the number they see, subtracting a negative is plus pi over 6. And then on the end it says vertical shift is plus 7. Last step, just distribute that through and write your answer on the line. So we've got 1/3 x, straight across on top is pi, straight across on bottom is 18, closing it, putting your plus 7, and that's it. Okay, be sure if you have any questions on this to come see me.